Probably not even going to be useful, but I just want to know what you guys, if you have any particular other questions beyond that. And then I'm also going to pull up chat for assignment 5B. Oh, sorry. Thank you. For assignment 5B, the official due date is Thursday. I think I was trying to, and I need to double check it, trying to make the hard deadline where it cuts off Saturday. The deadlines for most assignments, I have been leaving the deadlines, the actual deadlines, the posted deadlines, the same for a damn good reason. Because if you can do 5B, you understand objects, you're okay for the exam. It's helping you with the exam. That's the reason we have it. So it's not perfect for reviewing for the exam. You have another new concept in there, but doing that assignment, you will go, oh, there's inheritance in action. Oh, there's polymorphism in action. There's like 4 different kinds of polymorphism in that darn assignment. No, 3. There's lots of polymorphism in there. Won't be exactly similar to assignment exam 2. So is the sample exam the same as exam 2? No. Well, one is online. The other one was designed for a paper exam. 2, I was highly opposed to multiple choice questions. I don't know if it has a multiple choice question, but I made that 2019, I guess, originally, and modified it since then. But the sample exam is designed for, it's probably longer than the actual exam because I figured out I can really crush people's hopes and dreams. Found that out in 2019. I can be worse in terms of how nasty an assignment or an exam question is. Honest, I'm trying not to be a jerk, but the sample exam, if you do it, fantastic practice. Is it exactly the same as the exam? No, not exactly the same. But if you do that sample exam, will it be prepared? You'll probably be pretty darn prepared. It's covering the same topics as well. So it's going all the way up to polymorphism. We do not do MFC or model view controller. Oh, a star is going to be way harder, but I can try something. As you might imagine, manually drawing out a star that scales depending on what you're looking at, the math involved in figuring out where all the different coordinate points are. That's actually the challenge for it. I might be able to do something like that. Yeah, I have to, because you got to figure out all the different ways to do it. But you can do other shapes other than triangles. You could do a pentagram or a pentagon, sorry, or hexagon or whatever the case is. That would be fine. Are we going to define a class with getter and setter method? You certainly could. So one of the nice things. So if you think about it, maybe this is bad advice to give you guys, but I like it as advice because it's what the advice I would have wanted as an undergraduate. What is easy for the professor to do? What's going to make sure that the questions that are being answered are not going to get people going off on weird tangents, right? So it needs to be constrained enough that everyone's answering the same question. It's not make a class. That would be stupid, right? Everyone would have different answers and there'd be no objective way of measuring that. But if I say make a huge class with all of these things and nothing's filled in, that's also going to be too hard. It's too much coding for an exam. What you want to be finding is things that are small enough, or you can constrain the space so that you clearly understand the topics and that you can apply what you've learned without necessarily writing 400 lines of code or something like that for an assignment. It could still getters and setters, though, perfectly fair game, right? That is what you would expect to see. So, you have a class with 2 variables and the getters and setters associated with that, and some other thing to print it out to the screen. So, there you go, the book class that I had here. What I could do is say, here is the book class. This is from a previous synchronized lecture that we were doing. It has an author, a title, let's say current pages, the number of pages. So this would be perfectly fair game. Here is all of my different functions for the book class. Write book.cpp. That would be a fair game question, right? Here's an author, here's the title. You also need to know how strings work in order to do this. We would have getter and setter methods for each of those things, but not for all the cases. I have the set number of pages, start the number of the start of the book, so resets everything, turn the page, which changes the current page, increases it by 1. And maybe I have a toString function. Oh, wait, because when I have the library book, the library book class, you could actually have to implement the library book class and modify it slightly. Things like that. It's hitting a bunch of things. Maybe we have to do some form of polymorphism. So what would be a good form of polymorphism? Oh, there we go. So here's our polymorphism, and void set author polymorphism. That's an overloaded function. I have two functions, both named set author, with two different inputs, one with a string, one with a character string or C string. Two different things. Do you understand how polymorphism works, right? Depending on which of these functions get called, depends on the kind of input that gets passed in, right? That's the kind of thing that you would expect maybe see. So you could definitely be asked to define a function or define a class. Absolutely. It's completely fair game. You've been doing it since assignment 2B, right? Assignment 2B, assignment 3, which is a two-parter with a media, and then 5B, which is this week, also covers that particular material, and all the labs that we've been working on, including the zombie labs, all cover that material. And yeah, we've been hitting those a bunch, and a whole bunch of examples in lectures.
Yeah, sir, I have a question.
Sure. I didn't. All right, I got to turn up the volume. All right, you go. There you go.
Yeah, it's on polymorphism. If I could share my screen, I had a practice.
All right, let me see here. Make co-host. You're good to go. I think I need to get out of my sharing stuff. Okay, you're good to go to share if you want to share. All right. Okay. By the way, your functions, we normally start function names and variables with a lowercase, but that's be nitpicking. That's just purely the subtleties, like naming conventions, much like all caps is yelling in a text message, that sort of thing. The student age. Okay. So what do you? Oh, you're muted.
Oh yeah, sorry. So if you notice up here, I updated the name of the professor and the TA, but the updated names don't show here.
BIT2400 is a class. Okay.
Oh, oh, you can share my screen. Hold on.
Yeah, you're sharing it right now.
Yeah, but can you see the program that's successfully run?
No, that's not on the screen right now.
Okay. 1 second. I'm trying it. Um, share screen. Yeah. Uh, yeah. So basically, the name is updated, the year and the TA's name and everything. But in this last beat, it's not updated. It's still the default setting.
Okay. Oh wait, nice example. I like it. So let's go back to. I wish I was 32 years old. All right, let's go back. Maybe that's my hex age. All right, let's see what. Okay, set student. So George is a student. You set the student. You did set all. Where are you setting the professor for? Oh, because they're part of the class, right?
Yeah.
But did you add George to the class? Bit
Uh,
2400, what does it take?
between 400, that's the class. This.
We should probably name it something else than class. So let's have a look. So we have professor's age for the class itself. We have a string professor name, TA's name, and then do we have a class roster? No. So how do you associate the student with the class with this course? Of course you don't.
Okay.
Right?
That's under here. Class students, public class.
Oh, wait.
Yeah, this is the I used inheritance for this. So this is like the child
There's a
class.
child class,
Yeah.
but that means the student, oh, has a professor, has a TA, has a
Yeah.
course name, has all this information plus the individual information about the student.
Yeah.
That's a weird way of looking at it. It's like you owning BIT2400, but good enough. That works for me, right? It's every other student is using BIT2400 as well. So you would expect BIT2400 to maybe have an array of students involved in it, a roster. Or maybe you would expect BIT2400 being a class and each student has a pointer to the classes that they're in, right? But I'll go with it. So this works fine for me. Okay, so we have this, we have, and it's private. Okay. And how are you getting the professor's name? Or yeah, the John Doe professor thing.
1 second. How did I do that? Okay, yeah, I think that
Okay,
should be, yeah.
this get professor name. Okay, and so when do you set the professor's name? So let's go back to George. George. George is a what's a constructor for George?
I used George. I used sorry, 1 second.
Mhm.
Uh how did I set it again?
Constructors where?
Yeah, get student name, blah blah, not this, not this.
Is that our constructor? Is the name of the class? It's type class. Yeah, there's a blank constructor.
Yeah, this is
Student class. Okay. Where's the professor's name changed?
the professor's name is changed right here.
That's a different class. That's a different object. You are not the other students in this class. You are not Daniel, for example. So if Daniel changes his course instructor, it doesn't change your course instructor.
Okay.
So
So
BIT2400 is a class. It has a course instructor. George has a course instructor as well somehow. George, it's a bit wonky in that fact, right? A student is not the same as a class, but we'll pretend that. So
yeah, but yeah, sorry. But since it's like okay, so I said this then to the professor's name, doesn't it like refer to the set professor's name I said earlier on?
no, that's a different object, completely different. Each object has its own variables inside of it. Think of them as wrapped up. So you have a student number. If you
Okay.
change your student number, it doesn't change Giovanni's, right? It doesn't change anyone else's student number. It just changes yours. You
Oh,
are the object. So if you change your student number, it only affects you.
okay.
But if you go back to your main method, look at what happens with air. BIT2400 is a class. If you change anything in it, it only affects that one object, that thing that has those variables inside of it.
All
Student
right.
George is a completely different object, has the same variable names, but completely different data. Just like you have a different name than other people in the class. You both have names, but they're very different. They don't share information at all. So George has a professor. George's professor is John Doe. You haven't set the name of the professor at all.
Okay, so I
So
need
you
to
would say
set it like
George dot set all David Sprague Patrick 3228, and that would do it. But you'd
oh
have to set George's professor and George's PA.
okay.
Oh, you're doing it there. You just did use the wrong variable. So bit2400 set all instead of bit2400 set all that second time, call George dot set all, and that'll
Okay,
fix the
but
flagging.
I didn't have like a void class of George the settle in the header. Does that matter? Does that like
Let's see if it caused an error.
okay?
Where's set all defined? Can you show me where set all is defined? We'll use this as an example as well. Set
Yes.
all, what? Okay, and set all dot h. Okay, let's go up a tiny bit. Let's see where it's listed under public. So what does that mean?
Oh, any class could use it. Yeah. Yeah.
There you go. Anyone can use it. Anyone can call it. And so your child class gets it for free.
Okay. Okay.
If it was private, you'd be out of luck. You'd be really, but you wouldn't be able to call the function either, but you'd be completely out of luck. All right, I'm also going to eat my snack because I'm hungry and I made oatmeal for myself.
I'm trying to run it.
Run it, see what happens.
Uh,
Everyone's afraid to run it. Just run it. Find out.
okay.
Do a little bit. Check it out. Not lunch, technically. I have little snacks as well, but thanks, Daniel. Actually, I'm excited to see what happens here. And maybe it's wrong. Let's find out.
Can you see?
You changed? It changed.
Okay. Yeah. All right.
Nice. Great. So what did you get in here? You got polymorphism. Do we have polymorphism? I'm not sure we have polymorphism. We have inheritance for sure. You called set all, and that sets everything up for you, right? And you got it for free. You didn't have to do squat, which is really nice.
Yeah.
We also looked at the fact that each object, every time we make a student object or a bit class object, let's call it a course object. Each one is unique. It's its own special little snowflake, right? It has its own variables. It has its own special information. I shouldn't use the term snowflake. Steve Bannon broke that term for me, right? But it makes its own variables that it has for itself. So it doesn't share data across the way. Much like when I make a new string, it's a different string, right? It's not sharing data with other things.
Okay.
That's sort of the point of object-oriented programming. Now, if you want, we can, does that answer your big question, or was there another part that you wanted to look at?
Yeah, I think that's all. Lastly, so in polymorphism, do we like in the main class, do we have to like put for instance, virtual void set all?
It's not a memorization thing, right? So we need to figure out what the virtual does, right? It's not just something you just,
Yeah.
every single time it looks like that. So just the void means what? It's the return type, right?
Yeah.
So if you go to any of your function, it has some kind of return type. It's either a double, an int, a this or that. If it's a void, it means it returns nothing, but that's what, it doesn't return anything, but it's still a function. That makes sense? The
Yeah.
virtual is a different beast altogether. So let's go to student.h maybe, or class. Let's do class.h. Okay. So you're defining your functions directly in there. That's fine. It's just, I don't normally put them in my header file. I normally move them in the definitions in my CPP file, but that's not the end of the world. Okay. Get TA name. What would happen if I put the word virtual there? So for get TA name, if I put the word virtual there, what do you think is going to happen? It's going to be tricky, by the way.
I think you'll be able to change the data inside. I'm not really sure.
Well, virtual is very confusing for a lot of people, so it's perfectly normal, but that's why I want to make sure we go over it. Virtual sounds fancier, weirder than it actually is still weird. Virtual is used for what's called runtime polymorphism. Big lecture on that series of lectures. Runtime polymorphism means when I call the function, I go and figure out which version of the function I call. I don't do it in advance. I can't do it when I'm compiling. I do it at runtime. When I'm actually running my code, that's when I figure out where it goes.
Okay.
Oh, sorry, it makes a backup of a function that's redefined. It doesn't have to be redefined. So right now, Ethan, that's a good point. So right now, get TA name, it's a virtual function, and the child class will use a virtual function, and all subsequent child classes it'll be virtual for it. And every single one of them will point to that definition of get TA name, because we don't have it in the child class. But let's say I have a bunch of shapes. This is where we saw it where we would see it in the assignment this week. We have a bunch of shapes. And all I do is I go to each one of the shapes. It's an array of shapes. That's all I have. And I say paint, 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 or shape views. Okay. I go to each one of these shape views and I go paint, 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 paint to each one of them. When I do that, it has to figure out which version of paint to call. And it does that by it being a virtual function. It goes into the function and goes, which version do I want to call? Oh, that one over there for circles. And it goes and calls the circle version of paint. It figures out which function to call based off of what type of object it is. Because we have an array of pointers to shapes, shape 2400s. We have an array of pointers to views. I think they're shape views, right? But they're circle views, rectangle views, they're child classes. It says it's a pointer to a shape view, but they're really actually child classes. And if you do have to do something like that, that's where the virtual function comes in. Because at runtime, you call paint and it figures out which paint call to make. So this is compile time polymorphism. Absolutely right. Right? No, not compile time, runtime polymorphism. Compile time polymorphism, you can view it different ways, but if I redefine, so let's make, if we wanted to, we could write get TA age in student.h. I could redefine it there. If I have a student object and I call get TA age, I will call the student.h's version of that function. I don't have to look up which one I'm doing. I'm in a student. I know it's a student. I call that one. But if I have a pointer to, when we're talking about our shapes in the assignment, if I have a pointer to a shape, I don't know what kind of shape it is. It's just a pointer to the shape. It's some kind of shape. It's not a circle. It's a pointer to a circle, but it's a pointer. I don't know what kind of shape it is. That's where runtime polymorphism comes in. That's why we have virtual functions, because otherwise you don't know which function to call. This would be it would go to the child class first. If it doesn't have it, then it goes to the parent. If it doesn't have it, then it goes to the grandparent. Is the second choice. Yeah, you can think of it like the second choice. So runtime polymorphism figures out which version I should be using. If I have multiple versions of the same function, just in different classes, the class has a function called get professor age. The child class has a function called get professor age. The grandchild function has a function called get professor age. And I just have a bunch of what's the name of the class? Class. I have a bunch of class pointers to this. Right, some of them are students, some of them are this, some of them are that. I figure it out on the fly. That it's hard to quite describe that one. But the idea is if I have, when I'm calling my function, my different types of polymorphism that I have coercion, which is, some people don't call it polymorphism. That's our casting. When I say, no, 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 it's not an integer, it's a double. Casting. It's polymorphism of our data, changing our data. Just, no, no, I'm not going to think of that. It's not an unsigned integer. It's just an integer, right? Casting. I have overloading. So overloading is if I have the same function two different places with two different things. I don't have an example of overloading in here in your code, George. So let me show you mine. There we go. This is a form of overloading right here. Which one am I calling? Depends on what my input parameters are. You give me a different input, I will call the other function. By the way, this is also overloading. Two constructors, two different inputs. Which constructor do I call? The one that matches the parameters. Is that making sense? So that's our overloading. That's another kind of polymorphism. We have templates. So that would actually be what we would call a compile time polymorphism. I can figure it out in advance at compile time. So if I have, we had library book, right? Okay, library book, we had a toString in library book, right? Let me double check some of these things here. Here's my toString in, okay, this is a virtual function called toString in book. I have the same function, toString, in its child class, library book. When I call toString, it will figure out if I, so let me go to Catchup demo and let me, there we go. This is, I'm going to make, I made a, let me see here, string, I have a book page, okay. I'm going to make a library book. It's, oh, there it is. An array of pointers to books. Some are library books. They may not be. They might be normal books. Runtime polymorphism will call the right function. Even I just know they're books. Some are library books, some are not. It'll figure out which one it is on the fly when I'm running it. That's runtime. I should have one for another kind of polymorphism. So let's do, oh, there it is. This is a form of overloading technically. This is compile time. It's still using toString, but I'm not using the virtual really. I happen to know it is a book. It's not a pointer to a book. It definitely is a book. If I change this to library book, let's say, hopefully that's going to work. Oh, library book, right? If I change this to library book, and then I do the toString, it's going to call the library book's version of toString. Let's test this out. Let me prove this to you guys. So, okay, I'm just compiling my code, generating my code. All right. So this is what this code will look like for right now. I have a library book. It has anonymous 10 pages. Okay. Okay, this is my first one. That's this line right here is being printed off right there. I'm on page 3 of the Order of the Phoenix. Okay, it's a library book. It says it right there. It is a library book, honest. Because I said toString on a library book. All these other things say library book as well. Let's switch off the word virtual. So just in case you don't believe me, getting rid of the word virtual here. Let's get rid of it here as well. I actually technically don't even need it here, but I'm going to get rid of it anyways. I'm going to recompile everything. What you're going to see, let me predict the future. I predict that you are going to see Order of the Phoenix on page 3. It's still a library book, but all the other ones are now just normal books. They're not library books anymore. That's the difference between runtime and compile time polymorphism. So here's hoping at least. Anytime. Do I have one of those? There we go. Visual Studio. Okay. So it is a library book, the first one. And oh, they're all, what the heck? They shouldn't be library books anymore. Let's compile it again and save it again. And oh, it's up to date. So why is it calling the right way? New library book. It's an array of library books. Oh, it says library book, but it's not actually a library book. We're going to see whether it says library book here. Let's run it again. All right. It's saying library book, but it's not actually a library book. The word, when it says it's a library book, it actually says the word is a library book that is on blah, blah, blah. This thing says has 10 pages and you are on page 1. It's a completely different output between a library book and a book. The only thing I did was get rid of the word virtual. The reason is I have an array of pointers to books. Some are library books, some are normal books. If I don't have the word virtual, I don't know which I'm just going to call the book's version of toString. If it says if I officially say, yeah, this thing is a library book, I'm going to call the library books version of it. But I don't know that the things in here are library books or not. I just know they're kinds of books. So I call the parents class, I call the books version of toString because I just know they're books. They're pointers to books. I need virtual in this case, so that at runtime, when I'm running my code, I figure out which version I do. That's what the virtual table's for. It's a lookup table to figure out which version of a function I have. And that's runtime polymorphism. This calling, toString here, that is overloading. I remove the old version of toString and use the child's version of it. Or I might have library book that takes in 3 different parameters, but I might have, do I have another example of this? Can I do this one? Oh, come on. B2, not very original. All right, that work? Right. Which version of the constructor am I calling here? There's no parameters going in. So when I jump over to book, which one am I doing? I'm doing this one right here, the one that doesn't take parameters. How about the other time I make a new library book, B1? It takes in 3 parameters. I'm going to call that version of the constructor. That's another kind of overloading. I have the same function, multiple instances of the same function, and I figure out which one I use based on what input is being used. That makes some sense, hopefully. I hope I dream. I think I turned off my chat, so let me pull up that here. All right. Would overloading be like when we switch the parameters of a function? That is a form of overloading. Beautiful. Like when we click up or down arrow to switch. Oh, with the when you look at the different options for the function calls, absolutely. So if I have this string title, so title, if I say title dot and then append, which one do I want? Yep, they're all overloaded. Overloaded functions right here. Nice. Perfect example. That's overloading in action. Different input parameters called different functions, but they're all called append because they all just append things. When I say get me the length of something or append something, I don't want to have to know what kind of thing. I just append it. Just put it in there. That's fine. Yes, exactly, Ethan. When a function is declared multiple times with different input parameters, or if I declare it in the child class and the parent class, but I don't have this virtual thing, right? If I'm in the child class, I'm going to call the child's version of it by default. And if it isn't defined in the child, I'll be calling the parent's version of it by default. It is very wild. It takes some time. It takes some practice. The virtual thing is the real kick in the pants. Information hiding is wild as well. I mean, right? We have this public-private protected thing, meaning I need to know who has access to my information. Because much like your social insurance number, much like your student card, you don't want to be giving that to anybody, right? There are certain things you probably have I'm assuming many of you have a junk email address. Maybe you don't. Maybe you will get one soon enough when you realize how bad, how much junk mail you get, right? My wife has this wonderful email address called junk mail. Right? It's her junk mail. It's her Gmail address that takes junk mail. She never checks it and doesn't look at it. It's just there. But it's great, right? You can give that out to anybody you want. Why? Because who cares? Some things like your social, you don't want to be giving that to people. Okay. We're only 12 commands. Assembly is far worse. The go-to statement alone is like punching yourself in the face. Whether private, protected, and public again. Absolutely. So let's honestly, a go-to statement is far more dangerous than any of this crap. The virtual is the one that's really overly powerful, I think, personally. I'm going to put those virtuals back in, by the way, because I think I need to. Right. So, And that's one, and public and private is also one that, and inheritance. Yeah, there are some dangerous things for sure. I will grant you, absolutely, there are some very, very dangerous parts. C itself is just infamously difficult, and C and C++ are infamously difficult. You build your own everything. You roll all your own solutions, and just one little mistake and breaks everything afterwards. Um, JavaScript's worse though, because you make a typo and it won't recognize anything at all. C is extraordinarily low level. Um, I'm not a huge fan of it as a teaching language, but I don't get to choose that. I know it myself, so, but I don't choose the language that you guys learn. I'm trying to push a bit more for Python in the near future, but me too. Yes, you want to go back to Scratch. Scratch, though, doesn't allow you to do everything. You cannot make a proper industrial game in Scratch. You can do that in C. You can do that in C++, especially C++. Um, it's small basic or all basic. Um, small basic and actual firm version of basic. There's too many languages. Oh, there's also too many languages. We should learn Rust. Oh, nice, cool. Um, so let's have a look. So I put that virtual in there. Let's go over what this public-private thing is. We learned, what was it that, Dr. Racket as a language. It's a functional language. If you didn't like functions, there's no variables. It's only functions for the entire language. It's fun. Okay, so what does this private and public thing do? Let's change things up a little bit. Let me see here. Let me do this as protected, and let's see what happens. All right, it's going to break a bunch of stuff. It will break it quite badly, actually. Let's move it actually one set available, set. Okay, I'll move it down a little bit. We're going to break our code quite nicely. So let's see what happens here. Public means anyone has access to it. Anyone can call it. Anyone can see it. If I have an instance of a library book or a book of any form, I can do this. That's what public means. It is completely free for all. You can do whatever you want. Does it break? Hey, it still works. Okay. Let's break it though, because I like breaking things. You can if you're dumb enough to let people do it. Yes, that's exactly right. So toString, notice we didn't do it. But in order to make, all my constructors are almost always public, or most time public, because you need to be able to make these things. And so edit from outside the class. So let's do, so my constructors, when I make a library book, I need to be able to call it. So that has to be public. This thing, toString, it's going to output some text. That seems safe. Make it public. That's fine. Is available. I was making it public before. It's not public anymore. Let's go to Catchup demo and see what happens here. And I have a library book here. Let's see, b2 dot. Oh, should be able to just call b2 dot. Why isn't it letting me? Let's save it and see what happens. Should have just let me keep typing though. That's weird. What's going on here? Okay. b2 dot. Why is that not letting me continue this? Library book b1 dot. Okay, I don't know why the b2 is not working, but b1. Let's do b1. Okay, so let is available, right? It's a library book, right? Is wait, what? Go find is available, right? It is nowhere in here. Is available. This function I made for library book is available. Said available is no longer available. There's no way I can access the function. It doesn't know the function exists. It's protected. It's inside that class. It's only the class or child classes of it can see that. So public, anyone's game. Protected, me and my family. If I have a child class, it can see that function. No one else can. Me, my child classes, that's it. Um, Friends will also see it, but friends are normally not Jennifer Aniston friends, but friend classes. So grandchildren can see it as well, because the child class can see it, the grandchild class can see it as well, unless the child class makes it private. Yeah. The parent doesn't even know the child exists. Yeah, that sounds really dirty and horrible and like they're bastard children or something like that. But honestly, it's you're not supposed to know about your child classes. So if I make the shape class, I shouldn't have to know the next 15 different shapes you make. The person making the new shape should know about it. But once you make the parent class, this base class, you shouldn't have to know what every other person coming along, every Tom, Dick, and Harry is going to be making some other class using your code. You shouldn't have to change your code to fit them. They fit to you. Nice. Okay. So I don't even have is available anymore. All right, let's put that back. Let's see what we have here. This is protected still. So I cannot call is available. That's why, but I wasn't calling is available from some other class. So that was the problem. Let's actually change it up over here. Let's go to book.h. So they're all public right now. Turn page, start page, set number of pages, set author. Let me save a good thing. So notice set author. Yeah, I'm allowing you to modify the author at, there's some things that I'm just letting it happen. But the example I was giving when I made this was if you want people to prevent them saying the author's name is Holden McGroin, Seymour Butts, or whatever juvenile name you want to go with. That's where you put tests to make sure that the names are not Seymour Butts or anonymous or no name at all, right? You can check the input, make sure it's safe, then change the author. Make sure it's an actual registered author before you change the name of the book or the author of the book. Uh, Private, I thought was protect. No, it can't be protected. It's got to be private. It's one of those weird things that you normally don't want to leave it to the defaults, much like you set your variables no matter what. You want to be setting your visibility no matter what. So it's one of those things I don't keep it in my head because I don't want to do that. I want to put public, protected, private, be very explicit about it. Uh, it might be private or private-ish by default, because this is, I will always forget to put this in, and then it'll say that function doesn't exist, and I'll be like, what? Because of that. I want to get an example of this. So that author is not even defined, by the way, so I need to actually define that. Comment that out at least. I want a private or protected function in here. Well, let's do this one. Okay, set toString. Okay, I'm going to move my toString around. And protected. Okay. Variables are almost always private. Sometimes you might want them protected if you want your child class to be able to modify the variable. Some people don't even think that's a good idea because you don't want other people to be even your child to be able to modify your data directly. So you're very, very overprotective about your member variables, but your functions are normally public. You'll have private functions. If it's a helper function that nobody else should be touching, you make it a private function to make sure no one's doing some weird thing like not turn the page, but if I had something like setting the page number manually, right? So turn the page, call set page number. I don't want other people to be able to just set the page number, but maybe I want a private function for me that sets the page number. Yes, I would define it twice, once for each of the parameters. They're going to act differently. Actually, let me do that. Mhm. So maybe this is a bad use of time, but let's find out. Set author. Okay. Here we go. All right. So I'm going to have string new author, the author, set author, typing, not my friend today. Done. I can call the other function if I wanted to, right? If I have a whole lot of error checking in here, I can just convert the data to some other format and use the other format. So why is that barfing on me? Oh, STD. STD. Why is there something? But essentially, I can call the other version of the function if I want, and then just use the error checking in that one other place. Maybe I take in a point and I convert it to two integers and call the setting x and y position with two integers, right? You're just trying to make it so that it's easy. It's a convenience function. Like cout, I don't have to redefine it for, I don't have a whole bunch of different things. I can do cout and add a number, cout and then add a string, cout and add all these other things without having to worry about how it all works. I'm just putting things in my cout statement. It's actually an overloaded function. Yep, that's overloading. You've been using it for a while. Every single time you had a string that you appended with a plus, right? Two strings, you add a plus together, overloaded. It's an overloaded function. It's defining the plus operator to be something that it's not. It's concatenation if for the case of strings. I can have append where it appends in a single character. I may have an append defined taking in a string. I may have an append that takes in a character array. Three different inputs, but they're all appending. You want it to conceptually be the same for all three. That's why we do it that way, so that you don't have to be like, what's a new, oh, it's append 2.0, it's append 3.9. You just want it to be sort of, it just works. Yeah, thank you. Actually, yes, way shy of 10 minutes. Let's figure out if we have any last second things. I'm not going to figure this one out, I don't think, in this period of time. It's incompatible with void set author. Oh, because I didn't save it yet. I didn't set this. There we go. So other things that we, and there's my thing breaking down. I don't have access to turn page anymore. It's protected. The child class has access to it, but just random Joe public function doesn't have access to it anymore because I did this right here. All right. Other questions, if I can pack off any last questions. Otherwise, you should take off, relax, take a deep breath. Take your time. I mean, don't take too long, but don't rush into just coding randomly. Think about what the question's asking, methodically approach the problem, right? I could ask what a multiple choice question saying, is this, what kind of polymorphism is this? I could ask, give me an example of polymorphism in this piece of code, this kind of polymorphism in this piece of code. I could say, make a polymorphic function for this particular class. There's all sorts of different ways you can ask that question. They're all sort of hitting the same point, right? So yeah, they're variants on the same theme, if you will. We have not done templating polymorphism though. That's the third type. We're going to be getting into that soon. That allows us to, the vector class and a bunch of other classes you with the standard template library, if you've ever used any of those, it allows you to put anything you want in like a linked list or in a collection of different things. There could be, I'm not going to tell you one way or the other, but I like some debugging questions. I like some questions like that. They're shorter and they're less like write a bunch of code, but I don't want to say one way or the other. Type of polymorphism, parametric polymorphism. Yep. That's the one where depending on, I think I always mix it. I'm very bad with terms and terminology. That would be like templates. So you can make a linked list that stores integers, or it stores strings, or it can store something else. Not on the exam. We can't see it. We haven't done it. It's there. It exists, but it's kind of polymorphism, but it's not something that I can really grill you on. Anything else? Get rid of this affected here. And it should all compile now. There we go. Nice. Anything else? By the way, I added the virtual back in, so let's just validate that everything's running again. Oh, Visual Studio, why do you do this to me? There we go. Okay, and to do is a library book. They're all library books again. Okay. Well, you could I could ask you to fill in, make a .h file or make a .cpp file or make both technically, and you can submit two different files. That would be fine. I mean, they just can't be big files because that's a lot of writing and shouldn't be that much writing. If you expect, you can judge the base of the amount of time you have for the question is about how much you should be writing or how long it'll take you to type, essentially, or to work on it. Also, if you don't want to type it in Visual Studio, you can just type it in the text field. We're not testing whether it compiles or not. We're testing whether you're close enough. Like, if I clearly understand that what you're doing, but you have a typo in there, if it's just gibberish, I can't get points for that. But if it looks like you're doing the right code, um, minor syntax errors are not going to take off many points. They might take off a point or two. And that could be you typing in the .cpp file. All right. I'm going to let you guys go because you have 3 minutes to start up the exam. I'm just going to be on Discord. If anybody has, do private direct messages with me, and then I can pass that on to other people. But I'm going to make a post about that right about now. All right. All right. Thank you, everyone, and I will see you on the other side. Bye.